Hey guys, welcome to my channel and I'm back again with another really interesting video. And in this video guys, we are going to see how you can evaluate your large language models without writing any single line of code, or if you are a developer, then with which Python libraries you can evaluate your large language model with a very short and small code snippet. So without taking any time further, let's get started with our video. So first thing first guys, it is really important for us to actually evaluate our large language models, because we need to make sure that do I use this large language model for a certain task or not. And if you want to make a decision on that, or if you want to know which language model is better than the other one, you need to have certain metrics, right? So there you go guys. In Hugging Face you will see plenty of applications where you can actually just place your model and you can find out how it performs on a lot of different criterias. So first thing first guys, we are going to learn how you can evaluate your model without writing any single line of code in Hugging Face. And to do that guys, as you can see on my screen, I have a space open which is called as Open LLM Leaderboard. So to evaluate your models, all you have to do is open this space. And if you don't know how I landed up on this page, all you do is you just go to huggingface.com. Okay, so I'll just remove this. So you just go to Hugging Face, and once you open it, you just go to the spaces. Okay, so you go to spaces, and then in the spaces you can just search here leaderboard. So search here leaderboard, and one of the first leaderboard spaces that is going to come is going to be the Open LLM Leaderboard. So that is how I landed on that page guys. Once you land on this page, you will see that this Open LLM Leaderboard basically is a Hugging Face application that ranks all the models on the basis of a lot of different criteria. So if I just scroll a bit down, you can see that it has given a lot of benchmarks for your large language models to perform on. For example, the average, the ARC, the Hella Swag, MMLU, Truthful, QA, Vinograde, GSMK, etc. etc. And you will see that there are many models which are mentioned here, and all these models are ranked on the basis of their average score, ARC, Hella Swag, and all these models have those scores listed against them. Okay. So let's say if you want to have a model for which you want a better accuracy, right? So you need the better accuracy. So ARC score is basically your accuracy score. So you just sort on the basis of your accuracy score. You can just click on it, and then it's going to sort it. So you can see it's sorting it. And whichever model comes the topmost, you can take that model. You can also make sure that, let's say I want the merged models for my use case. So you can click on the merged part, and then it is going to show you which of the models are merged or not. Okay, if you want to filter on the basis of the number of billions of parameters, for example, if you want a smaller model, you want like 1.5 billion parameters, so that's good enough for you. So you can uncheck all these and you can just check the 1.5 billion parameters. Also, for example, if you want your precision, so why is precision important guys? In my last video I was telling you about the quantized model, right? So for your quantized model, you need to make sure that you are able to run them in a certain hardware that you have, right? So let's say you have a GPU which only supports 4-bit quantized, then you can just uncheck all these models and you just select 4-bit. If you have a GPT-Q model that you want to run, then you can just uncheck all the other precision and just check GPT-Q. If you want to have a really nice and large model, you can just select precision float 16, which is one of the best precision that we have. And by this guys, you will see on this leaderboard all the filters or check or uncheck, whatever you do, you will see the filtered models on this leaderboard. And out of these models also, you can just take the columns or the metrics that you are most concerned about, and then you can just sort it on the basis of that, right? So for example, truthful QA is more about question answering, like how truthfully your model is answering the questions, right? So you can just sort on that. If your model is based upon question answering and you want to find out the best model in that scenario, right? So all these metrics actually define a certain measurement. So if you want to go through what all these metrics mean, then please do write down in the comment section below, guys. I'll make a separate video on then all of these different metrics. But for now, you can just understand that Open LLM Leaderboard gives you a fully fledged UI where you can sort the models, select the models on the basis of many different criteria, and you can just compare all their metrics. Okay, there's one more thing that you can select the model types also here, guys. So for example, if you want to only select the models that are pre-trained, you can uncheck everything, just select pre-trained. You want only the model types which are fine-tuned of certain domain specific data set, something like this, you can just check that. If you want, some base merges, for example, if you want to only select models that can be used as a base for merging other models, you can select that, right? If you want chat models, you can select this one. So there are a whole lot of filters in this Open LLM leaderboard that you can use to simply filter out the models, and then here in this table you can just sort the models on the basis of the certain metric that you want to evaluate it on, right? That is about the Open LLM leaderboard, and that is how you can use these benchmarks to select the correct model. But our video was not about selecting the correct model, guys. This video was actually how you can evaluate your own model. For that, guys, we'll just use this small form here which is called as submit here, right? So once you click on submit here, guys, you will see a small little detail that you have to fill, and then you just click on submit eval. So first thing is your model name. So let's say, guys, that this is my model name. So in the last video we created this quantized model. So I'm just going to put the model name here. What is the precision of the model? So guys, when we created this model and when we pushed it into the Huggingface, Huggingface by default, not by default, but once you push a model into Huggingface will give it a precision, and that precision you can see here. So it's a 4-bit precision. So all you do is just select that it is a 4-bit precision. Then weights type, obviously, guys, this is the original model, so we didn't use a weight from any other place. So we're just gonna select original. Then select the revision commit, which is the main commit, because we didn't create multiple revisions of this. We just created one revision, right? Model type, was this model a fine-tuned model or a pre-trained model? So this was definitely a pre-trained model, guys, because we did not fine-tune the model. We just quantized it, but we didn't fine-tune it, right? And then base model for the delta or adapter weights, because this was an original model. We didn't create the model from any base model, so we can just leave it as blank, right? One more thing is important here, guys, that once you have a very newish model, so for example, this model was very new, there is a possibility that the license value of your model is not updated. So if a license value is not updated, then you will get an error when you submit the model in here, right? You will get an error that you need the license. So what I did was, because I did not have the license at that moment in time, I clicked on edit, and then once I click on edit, you can see that the license value here right now is filled as other, but previously there was no license value. It was like this, right? So we had to add a license, but now I added the license as other, and then I just saved this, right? So once you have the license added, you can just commit the changes to main, and then it will be done, right? So make sure that when you are evaluating a new model, make sure to add the license value, because if the license is not added, you will not be able to submit it to the Open LLM leaderboard for evaluation. But now that we have the license, we can just click on submit eval, and once you click on submit eval, guys, you can see that this says that the model has already been submitted, because I already submitted it. But if you are submitting the model for the very first time, you will get a green message saying that your model has been submitted for evaluation. It basically generally takes some 2-3 days to actually complete the evaluation, right? So now if I click on running evaluation, you might find my model already running. So let's try to find that. Okay, let's try to find that. No, it's not running, guys, but it is also the case that sometimes when you first submit a model for evaluation, it takes almost a day to even come into or to even reflect into the running evaluation queue. So sometimes it takes a longer time for you to just find your model in these evaluation queues, but after certain time you will be able to find your model. Okay, so for example, let me try to find out my model in the leaderboard. So if I go into the LLM benchmark here, and let me just try to find out the model, because I have submitted some of the models for evaluation before. Let's see if I can find one of them. So you can see that this super lazy coded neural pipe 7 billion parameter model was a model that I submitted a long time back, and it took a lot of time for it to get evaluated and get reflected here. But finally, after I think few days, few weeks or few days, it got reflected and you are able to see the score. And it is not just that, guys. Once you have your model being reflected into the Open LLM leaderboard, it is public. This is a public information, so anybody in the world can take this statistics of your model, can take these values of your model, and you can just simply and that person can simply may use this public information to use your model. Okay, so for example, if they see that your model is performing well on certain metrics, they will have the link to your model like this. They can click on that and they can go to your models card, and then they can just use as your model through code. This is a very good exercise, guys, to submit your model in Open LLM leaderboard, because then it becomes for everyone to check the performance of the model. You don't really have to code to evaluate your model. You don't have to do anything. You can just submit the model for evaluation, and then Open LLM leaderboard will do the job for you. Okay, so that is how you can use the Open LLM leaderboard, guys, to find out the correct model, to evaluate the models, and to submit your own models. But now we want to understand, as a developer, how I can evaluate my own models without submitting it to some Open LLM leaderboard space. And for that, we are going to use a API that Python provides, which is called as Evaluate. Okay, let's see how Evaluate works. So Evaluate API is basically a Python library which gives us a certain amount of metrics, a lot of metrics that we can use to load the data set for those metrics and use that data set for evaluating our model. And the way it works is that we just take the data set for our certain metric, we divide it or we split it into your training data or testing data or something like that, and after, on the basis of that split, you will use a certain amount of data for testing your model, and then the results of that will be placed into a dictionary, and then you can just use that dictionary to find out how your model performed. So that's just the theory part of it. I hope you understood that this is a very simple process. There is not much to it. Let's see through code how you can actually use this Evaluate API. So the first thing first is simply install it. So in this Google Colab notebook, I'm just using pip install evaluate, and there it goes. Now once you have installed it, you just need to import a evaluator from the Evaluate API. Okay. Now what is a evaluator, guys? So evaluator is basically a module that is provided by the Python, and this evaluator can take multiple arguments or multiple tasks as argument. Now what different type of tasks do a large language model can a large language model can have, right? So if you go to spaces, or sorry, if you go to models, basically you can see that we are filtering the models through tasks, and you can see how many tasks that we have here. We have got innumerable tasks. We have got text classification, we have got token classification, we have got image classification, we have got text generation, we have got tabular classification, and so on and so forth, right? So what this evaluator module does is that it takes the task as the argument. Okay, So the first thing is I am importing the evaluator, then I am importing the load dataset. Load dataset is a API that is going to use to load the dataset on which you want to evaluate your model, right? But now let's understand evaluator. You can see that evaluator object, basically you initialize it with the task. And on the basis of this task, you will use this evaluator to compute the results of your model. Okay. So now this evaluator can be initialized with a task like text classification, and later we will also see that it can be used to classify, it can be used for image generation, it can be used for question answering type of task as well, right? But just as an example, you can see that we have initialized it with a certain task. Now, once you have the evaluator created, the next thing is that you want to provide this evaluator with a data set to evaluate on. That data set, you can load that data set with the help of load data set module. So in the load data set, you are just going to provide the name of the data set and the split of the data set. So for example, in this case, I can say that the IMDb data set is going to be used, and then of that data set also, this data set will be divided into train and test. But out of that split of train test, I am only going to use the test data set part of it. So out of IMDb, I am only going to use the testing part of the IMDb data set, and for those testing part also I am only going to use first two columns. Okay, I'm not going to use all the columns in the test data set. I'm only going to use like first two values, right? First two rows, sorry. So we don't want to actually make this process much longer. That's why we are not taking a lot of data for testing. Okay. Now, once you have your data set, once you have your evaluator, it is time to start evaluating your model. So to evaluate your model, you are going to call the compute function on the evaluator object. Now this compute function is going to take certain parameters. First is going to be the model or the pipeline. So you know that for a model, either you can just specify the name of the model like this. You can copy the name of the model from the Huggingface. Or if you are using transformers to load a model, you can actually create a pipeline also. You can just give the name of the pipeline object here. But let's keep this simple. Let's only give the model name. Next thing is the data. So for example, this is the data set that you want to evaluate it on, right? So that becomes your data. Your data can also be a simple dictionary as well. The only thing is that you just need to make sure that your data set just matches with the model task that you want to evaluate. Third is the metric, right? So metric is accuracy in this case. As I told you that we have got so many metrics. We have got accuracy, we have got precision, we have got perplexity, we have got so many metrics with us. So it depends upon you what type of metric you want to evaluate on. So on that basis, you can just set the metric here. And then comes the label mapping, right? So for example, label 0, label 1. So this is basically the case where you want to make sure that so label mapping is basically the case when you are using a text classification, right? So let's say if a text classification is there, then you can basically say that certain label value is going to be the value 1 and certain other label is going to be value 2, right? So if you have a text classification where you are saying this text is label 1, this text is label 2, you are saying that the value of this label is going to be 1, value of this label is going to be, the value of this label is going to be 0, this label is going to be 1, right? So these are certain parameters like label mapping which you can use specifically for text classification, and you will see that these parameters definitely change when you use a different type of task, right? The strategy equals to bootstrap. So this is one of the strategy that you can use for evaluating your model, and this strategy can change as well. If you want to keep this simple, you can just remove this strategy as well, just to make sure that it runs a bit faster. Then the number of resamples and the random state. So number of resamples and the number of random state are not that important in this case, guys. We are not going to go deeper into what each of these parameters mean, but you can just say that, just to make this simple, even if you remove the the last three ones, and you can just keep the label mapping, the metric, the data and the model, then also you will be able to successfully calculate the metric of this model, the accuracy metric, right? Now let's see that once we executed this code, how did it behave? So once we executed this code, guys, you can see that it started to just load all the tokens, load your model, load your data set, and finally in the end it was able to execute the code. Okay, let's actually run this to see that what result do we get. So this is obviously going to take some time, guys, but hopefully this will get executed much quickly, and there you go, you can see that it got executed. Let's print the results. Let's see what are the results of the accuracy metric. And you can see here, guys, that it actually prints the accuracy metric with the confidence interval, the standard error, the score, the total time, samples per second, and the latency in second, right? So you can see that the accuracy score that we got was 0.5. So that becomes your accuracy score, okay? And we are calculating it in the confidence interval of 0 to 1. So between 0 to 1, it is scoring it on the basis of that, and we are getting the accuracy score of 0.5, and the error that we are getting is this much, right? And this is the time that was taken, and these are the samples per second we took to actually run this evaluation, and this is some latency in second that we have seen for evaluating the model, right? But you can see that with only a small snippet of code, how quickly, with a small data set only, you are able to find out what is the accuracy score of your model. Okay, so in this way, guys, you can just change the metric. You can change the metric to something like precision, is something like perplexity or something like that, and you can find out that score as well. Okay, let's go and see another example. Okay, so let's go and see another example. One of the other example that I wanted to show you was the task of question answering. So once you have a question answering task, guys, you just ask a question and then you answer it on the basis of that. So for that, guys, we are using a squad dataset, which is a scoring question answering dataset. Okay, so that's almost the full form of it, which is a scoring question answering dataset. And we are just taking the validation part of this dataset, and the validation part of this dataset only we are only taking first two rows, right, 0 to 2. Then we are doing the same thing. We are having the evaluator object, we calling the compute function. We are just passing three things here. So you can see that we are not even passing the label mapping. Why? Because this is not a classification task, it's a question answering task, and our situation is that we want to score how accurately or how in a best way it is able to answer the questions, right? So for that we only need three parameters. We need the model, we need the data, and we need the metric. That's the scoring question answering. So but for that, guys, you must have some knowledge of like which is the best metric that you need for something like question answering, right? And we know now that squad is one of the best metric to evaluate a question answering model. So this knowledge is also important, that which metric you have to use to evaluate your model. But once we have evaluated the model, guys, these are the results, and you can see that the exact match is 0. This is the F1 score. So you can see that the model is not very good because it might not be giving an exact match of the answers, and the F1 score is also 0, which is also not pretty good. However, we can still see that however it does show that we are able to compute evaluation score on a question answering model. So the code does work, but obviously the model is maybe not that good, and that's why we are not getting a better score. But you can use the same code to find out the score for some other better performing question answering model. Okay, and you can also try to choose a bigger data set than just 2 rows. You can maybe choose a bigger data set, like maybe the whole validation set, right? So this was the code to actually use the evaluator to use different type of task and find out how a certain model is performing the best on that task, right? But there is another thing you can do, and that is just using, you can still evaluate your model through another way, and that another way is not by using evaluator for a certain task, but you can just use an evaluate API. Now, how do we use a evaluate API? So in case of evaluate API, guys, you don't have to specify the task that you want to find out how your model performs best on that task. Evaluate API is used when you are sure of the metric. When you are a good data scientist and you know that I want to evaluate this metric for my data set. You're sure of the metric and you just want to know how it performs the best on that metric. Then you just use evaluate API. And one of the reason for that, and one of the main example of that is by evaluating the perplexity metric, right? Now, perplexity, guys, is a certain type of metric that can be used majorly for unsupervised data set. So something like a GPT model or a text generation model, we can use perplexity to actually evaluate that model. So, for example, accuracy is more for classification, where you just want to know how your model predicts the correct score out of the or how your model predicts the correct label or the correct value out of the all the values that are predicted. Okay, whereas perplexity majorly means what is the probability that your model is going to generate a certain input. Okay, so that is the perplexity part of it. So let's say if you want your model to generate an input or generate a summary of an essay or something, right? If you want your model to generate the simple code or some essay or something, right? So you can actually take that code or take that essay, give that as an input to this code, to this code snippet, and check what is the probability of your large language model to come up with such sentence or to come up with such text. If the probability is higher, it means that your model understands that text very well, and there is very high probability that if you ask some related question to that, it will come up with that text. But if the probability is much lower, then you can say that it might not be likely to generate that sort of text, right? So there are certain things that you can use perplexity to actually evaluate your model. Now here you can see the way we have done it is that you just load the metrics data, evaluate.load perplexity module type metric, and then you are giving certain input text. Okay, so this is some gibberish input text like happy birthday, lorem ipsum, be a venue, right? And then you use the metric perplexity to compute your model, right? And you just call compute, you give the ID of the model, you give a start token, that if you want to start from a certain token or not, but you can just otherwise give false. And then the prediction, so which input text you want to find out the perplexity on. So you just give the input text and you can see that the results come out like this. So for the first text, which is lorem ipsum, the probability is this much, and or the score is this much, that this is the chances that it's going to generate this. And then the second one, happy birthday, obviously you can see the score is very high because there is a very high chance that it is going to come up with there's a very low chance it is going to come up with gibberish like lorem ipsum, but there's a very high chance it is going to come up with a sentence like happy birthday. And be a venue, also there is a certain chance, but you can see that because this is a French word but this is not an English word, that's why the perplexity is lower. And then the mean perplexity is also somewhat given to you, right? So these are certain things, right? If you want to evaluate a unsupervised, like a text generation, something sort of model, you can use something like Perplexity. If you want a supervised data set where we just need, where we just need text classification or question answering sort of thing, where you actually know that these are the answers which are correct and these are the answers which are wrong, you can just use something called as accuracy or an evaluator with a certain task name to actually evaluate your model. But this is a way, guys, that you can evaluate your model yourself using the Evaluator API, or you can use Open LLM Leaderboard. If you don't have much knowledge about evaluating your models, you can just use Open LLM Leaderboard to actually just submit your model and find out how it scores against the other models without writing any single line of code. Okay. But that is all about evaluating your model, guys. This is a very basic video where I wanted to introduce you to the Evaluator API and also to the some of the metrics that we can use for evaluation. I hope this video was clear to you guys. I hope it made sense and it also gave you certain more insights into the world of large language models. If you did like this video, guys, then please do not forget to like this video, share this video with your friends. And guys, if you have any questions, comments, suggestions for me, please do write down in the comment section below. I will be really happy to read them and go through them. And in the end, guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.